Hello all, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to study a very important topic of class 10 NCERT, that is refractive index, and what are the principle, what is the physics behind refractive index, and what are the different types of refractive index also here. And we'll just do this thing, we'll just get the concepts clear with the help of some numericals, and then without wasting time, let us dive straight to the class. So to the class. So refractive index is defined as it's a ratio of velocity of light in vacuum or air to velocity of light in a medium. For example, this is a scenario. So there are two mediums, 1 and 2, and the first medium is air, and the light is coming from the air and it is entering to the second medium. Okay, as air is a rare medium and this particular second medium is a denser medium, we can say the light bent towards the normal. That is, this bending can be towards or away. And what is that thing? So we can say the principle goes like this: when the light moves from rarer medium to denser medium, then the light bend towards the normal. And when light moves from denser medium to rarer medium, we can see the light moves away from the normal. So this is a principle behind the bending of light and the refraction process. So this phenomenon, the total phenomenon, is known as refraction, and this refraction is due to the change in refractive index. So we have seen this, but the definition we have seen, refractive index is equal to the speed difference. The refraction process takes place due to speed difference, and the refractive index is calculated as the ratio of velocity of light in air or vacuum to velocity of light in that particular medium. So this is the case. Okay, so let us find what are the different types of refractive index. So there are mainly two types of refractive index, and that is absolute refractive index and relative refractive index. So what is the difference between this absolute refractive index and relative refractive index? Let us see what is the difference there. Okay, in the first case, the scenario is like this, that is, there are two medium, that is, one medium is air or vacuum and the second medium is one unknown medium with a particular refractive index. Okay, once the light moves from this air to this particular medium, then you can see it bend towards the normal, as light is a rarer medium. Okay, fine, this is the case there. Here, the refractive index of the second medium, that is, the light is bending at the second medium. So we are finding out the refractive index of that particular second medium, that is N2. Or simply, we will not write this 2 denotation here, we will not write it here. Simply N means the refractive index of this particular medium. Okay, so this is given as the ratio of velocity of light in air or vacuum to the velocity of light in this particular medium, which is given as Vm, or simply it is given as V2, which represents the velocity of light in that particular medium 2. That is, here this is the case there. Okay, and this is giving you the absolute refractive index of medium 2. Here the velocity of light in this particular medium is V2 and velocity here is C. We will not write V1. Why? Because the first medium is what? Air or vacuum, and it is denoted, that particular velocity of light is denoted with letter C. So this is given by N is equal to C by V2. Okay, so this is the case. If this is glass, this medium is glass, then instead of this 2 you need to write it is glass, that is velocity of light in a glass. If this is any medium, diamond, then you can say this is V diamond. It's up to you, up to the scenario, you need to find it out. Okay, this is about the absolute refractive index. So we are just relating, or we are just correlating the velocity of light with respect to air or vacuum, or the refractive index with respect to air or vacuum. This is the case in the case of a absolute refractive index. Whereas what is a relative refractive index? In this here you can see that instead of air and vacuum, there are two mediums, 1 and 2, and this medium is having a absolute refractive index of 1, and here it is having a value of absolute refractive index 2, and the velocity of light in this medium 1 is v1 and velocity of light in this medium 2 is v2. So these are the scenarios here. Here we are not relating the refractive index or velocity with respect to air or vacuum. Instead, we are saying that we are just, the light is coming or the light is entering from one medium to another medium. It can be towards the normal or it can be away from the normal. It's up to the rarer medium. With respect to, if you are just comparing this medium 1 and 2, we will see which one is optically denser, more optical denser than the other one. If 2 is more optically denser than 1, then this will become the denser medium and this will become the rarer medium. If this is optically less denser than medium 1, then this will become rarer medium and this will become denser medium. So it's up to the comparison. So there is no fixed rarer or denser medium, but air is considered as a rarer medium itself. So here in the case of relative refractive index, there is no permanent fixed denser or rarer mediums. We'll just compare among those two mediums and we'll find out which one is denser, which one is rarer medium. If medium 1 is rarer and medium 2 is denser, then obviously the light ray will move towards the normal according to the principle. Okay. Now, if I want to find out the density, because the light is bending in which medium? Here in this case, the light is bending in medium 2. So obviously we are going to find out the density, the relative, the refractive index of medium 2 with respect to 1. We will see in which medium the light is bending. In that medium, we are going to find out the refractive index. Keep that thing in your mind. Okay. So here N21. N21 denotes what? The refractive index of 2, the medium 2 with respect to refractive index of medium 1. So we are just comparing with medium 1 and just finding out the refractive index of medium 2. So N21 is giving you the value of a refractive index of 2 with respect to 1, and it is given as the ratio of refractive index of 2 with respect to absolute refractive index of 1. That is, N21 is the relative refractive index of 2 with respect to 1, and that is given by the ratio of absolute refractive index of 2 with respect to absolute refractive index of 1. So this is how you are finding out the relative refractive index. And if I want to find out N12, what do you mean by N12? Here, N12 means the light is moving from medium 2 to medium 1. Then what happens there? That is, the light is passing from medium 2 to medium 1. So obviously, in which medium the light is bending? Medium 1, it is bending. So we are finding out the refractive index of 1 with respect to 2, and that is given by the ratio of absolute refractive index of 1 with respect to absolute refractive index of 2. So this is how you are finding out the relative refractive index. Okay, more clearly. So here we had found the relative refractive index with respect to the absolute refractive index of the individual mediums. So what about the velocity? With respect to velocities also we can find out the relative refractive index. So how we can find it out? Just listen carefully. So I'm just going to rub this left side of the board. So just pause the video, write it down, and then listen carefully. Okay. By equation, N21 is equal to N2 by N1. Okay, fine. Okay, let us see a small thing here. You have all seen the definition of absolute refractive index, right? Absolute refractive index is given by the ratio of velocity of light in air or vacuum to velocity of light in that particular medium. Okay, so N2 means absolute refractive index of 2, N1 is absolute refractive index of 1. So instead of this absolute refractive index, I am just giving this value. So obviously N2 will become C by velocity of light in second medium, so V2, divided by, instead of N1, I am just writing C by V1, right? and this will give you the CC will get cancel out each other, and this will be equal to V1 by V2. So N21 or N21 is equal to V1 by V2. Similarly, if you're finding out N12, then you will get another relation, that is V2 by V1. So see the thing. Okay, in case of absolute refractive index, if I want to find out N21, then I'll get N2 by N1 directly. But whereas in this case of velocity of light, then that is equal to V1 by V2. So this is a case that you should understand properly. And here in this case N12, you know that it is equal to N1 by N2, but instead in case of velocity, if I want to find out, this will become just the reciprocal, that is N12 is equal to V2 by V1. So this is a case there. And one more very important relation is there. Here all you have seen N21 and N12, which is just the reciprocal. Here it is V1, here it is V1 by V2, here it is V2 by V1. So just the reciprocal. Here N2 by N1, here N1 by N2. So we can just get another very important equation, that is N21 is equal to reciprocal of N12. So here is another very important equation. N21 is equal to N12. So the reciprocal. So if you may get a question, that question may give you this value, and you will be asked to find out N12. Then that is so simple. That is so simple. So just take the reciprocal and get the values there. You will think that you will just, okay, they may give another credentials to just confuse you, but there is no need of any confusion. Just write it down, just take the reciprocal, get the answer. So simple. So that's all about the refractive index and the different types of refractive index. And that's the case. The only concept is that you just see in which medium the light is bending, and you will get, and you just say that the refractive index of that particular medium in which the light bends equal to so and so, and then you will get the values there. So this is a thing. So two types are there, that is with respect to refractive, absolute refractive index, you can find out the relative refractive index, and as well as the velocity, with respect to the velocities of light in the corresponding mediums, you can find out the relative refractive index. So that's all about the refractive index. So we'll do some numericals and then find out how we can just calculate the values of refractive index. Okay, so to the questions. The light enters from air into diamond, that is from air to diamond, which has a refractive index of 2.42. That is, the light is entering from where to where? Air to diamond. Okay, air to diamond. And so obviously what happens? Here bending takes place there, and the refractive index of diamond with respect to air, which is what? With respect to air or vacuum, it is another, otherwise it is called as what? It is simply the absolute refractive index, and that is given as n is equal to 2.42. Okay, and the speed of light in air is given as 3 into 10 raised to 8. You all know that is 3 into 10 raised to 8 meter per second. So here we need to find out the velocity of light in diamond. So you know the refractive index of diamond with respect to air is given as C by VD, right? Simply the simple equation. So from there you are just getting the values. What is NDA? It is this one, right? That is 2.42. That is equal to 3 into 10 raised to 8. That is given here. Divided by VD. So velocity of light in diamond. So VD is given as VD is equal to, so just take it here, and this one will come here. So 3 into 10 raised to 8 meter per second divided by 2.42. What is the unit of this refractive index? So there is no unit. So don't go for find out any units for refractive index. Why? Because there is no unit there. Why? Because it is a ratio of equal units, that is velocity by velocity or absolute refractive index to absolute refractive index. So there will be no units. Why? Because it's a ratio equations. Okay. So this is the case there. So what is the value here? By just calculating the values, you will get the answers there, and you will get approximately 1.24 into 10 raised to 8 meter per second here. Just listen carefully. Here, what is given there? The absolute refractive index is given there. Absolute refractive index is given as the velocity of light in air or vacuum to velocity of light in that particular medium, and here the medium is diamond, and you will get the values directly. Direct question, so simply 3 marks will be in your hands. So this will be asked as a sub question, so obviously 1 or 2 marks this question you will get the marks. Okay, so this is about the first question. Okay, now listen, just pause your video and then try to do yourself and see whether you get the correct answers and whether you are doing the correct concept, you are going with the correct concept and doing the correct steps. Okay, now to the second question. So see the question carefully. Okay, and write down all the credentials given, all the values, given values, and then you just find out the corresponding equations and then get the answers. Okay, let us see what happens here. So if the refractive index of water for light going from air to water be here, the refractive index of water is 1.33. What will be the refractive index for light going from water to air? This is what we need to find out. Okay. Now, what happens when the refractive index of light, once it goes from the refractive index of air with respect to water? Okay. So in this case, what happens there? So what do you know? What you need to know, that is V is equal to 3 into 10 raised to 8 meter per second, and then you need to find out the velocity of water, and then you want to just take the equation, that is N is equal to NW, A is equal to VA by VW. Is it so? No. You already know a very easy question, but you may get confused. If you're not knowing that particular equation, then you will not get the answer. Unless you by heart the velocity of light in air, water, diamond, then cold, and it goes. We need to by heart all those values. But is it so? No, it's not possible, because it's not easy to by heart. Yes, obviously you can by heart the values, but it's not easy in that short span of time. But if you know this equation, that is NW will be equal to the reciprocal of NA. One in this scenario, that is NWA is equal to 1 by NAW. That is, this is what? The reciprocal of light, the refractive index of light once it travels from air to water. This is what we need to find out. That is, this value is to be found out. That is, this value is already, we know the values there, right? So from there you will get, that is NAW, that is, once the light moves from water to air, what is the refractive index there? So NAW will be equal to 1 by NWA, and NWA is given there, so NAW is equal to 1 by 1.33, and you will get approximate value, that is 0.75. This will be the approximate value, or that is equal to the value you are going to get. Okay, so simple equation. Once you know this equation, then everything is easy. Why? Because you know, if two mediums are there, light moves from one medium to another medium, just take the reciprocal and you will get the refractive index of the other medium once it moves backward, or the reciprocal in the opposite direction. That is, first one is air to water, and then the second one is water to air. Okay, this is the case. Just pause the video and see whether you got the concept there, and it's so simple, so direct, and you will get an easy 1 mark or 2 marks for this particular question. So just do it yourself and listen to the third question. Now listen to the third question. Very interesting question, very easy question, and sometimes confusing questions too. Question 2. Okay, let us see what happens here. Here, read the question carefully, write down the given values. The refractive index of glass with respect to air, that is N G with respect to air, is equal to 3 by 2. Okay, fine. And the next one is that the refractive index of water with respect to air. with respect to air. So what happens there? NVWA is equal to 4 by 3. And you need to find out what is the refractive index of glass with respect to water. This is what you need to find out. So a bit confusing how to do this thing. Okay, simple thing. Just take a deep breath and then do it. NGA can be written as what? Ng by Na. What is that? It is a ratio of absolute refractive index of glass with respect to absolute refractive index of air. Okay, fine. And NWA can be written as N W by Na. Let this be equation 1, let this be equation 2. Okay, fine. And then I'm just dividing 1 divided by 2 equation, which implies what? Ng by Na divided by Nw by Na. So Na cancel, and what will you get? Gives you Ng by Nw. Right? So what is this Ng by Nw? Which implies what? The ratio of absolute refractive index of glass to ratio of absolute refractive index. The ratio of absolute refractive index of glass with respect to the absolute refractive index of water, which gives you the relative refractive index of glass with respect to water. Am I right? Yes. Right? So this is what you are getting. So if I am dividing this Nga with NWA, then I will get what? NGW. NGW. So NGW is equal to Nga divided by NWA, which is equal to, what are the values there? Nga is equal to 3 by 2 divided by 4 by 3, which will give you an answer that is 9 by 8. That is nothing but it is 1.125 will be the answer. So simple, but you may get confused. Why? Because there is no values given. The only value given is something else, and you are just dividing and you are getting the values there. So from the same question, if you are asked to find out what is NWG, or a refractive index of water with respect to glass, what will you do? Okay, if you divide and you get this answer, what will you do? Either you can just take the reciprocal of this value and you will get this value. Otherwise, instead of 1 divided by 2, you just divide 2 divided by 1. Then you will get this value. Okay, so simple question, so simple answer. So you will get an easy 3 marks or 2 marks for your board exams. So listen carefully. So you may get a bit confused there, because refractive index is the only portion where something new is studied there. Okay, or some confusion may occur, but if you get the concept, everything will be easy and clear. Okay, now the last question, which is for you guys to do as a homework, as a homework, and then do it and then get the answer, pin it in the comment, and then see whether you are getting the correct answer. Okay, and so here is a question, that is the absolute refractive index of glass. That is Ng is given there, that is 4 by 3, and absolute refractive index of water, that is Nw, is given there, that is 3 by 2. And you are asked, okay, one more value is given, the speed of light in glass is given there, that is 2 into 10 raised to 8 meter per second. And you are asked to find out the speed of light in vacuum and speed of light in water. So simple thing, so you can just easily access the answer. And you find out the speed of light in C, or air, or vacuum. Don't simply write 3 into 10 raised to 8 meter per second as you by heart that answer from the 7th standard onwards. But don't write that, because the answer requires the correct steps, and you need to do the steps and show that, okay, this is the procedure, and you know the procedure, and you get VA first, or V vacuum first, and then substitute that value here, and you will get the VW also. And just try to do that thing and see whether you are getting the answer. So that's it. So I hope that you got the points and concepts clear for refractive index, and just do the numericals and find out the answers. Do it once again, find out new questions, do it, and then make the concept clear for refractive index. So we'll come with another new topics and important questions in the next class. So we need your support by your like, share, comment and subscription. So do supporting. So we'll see you in the next class. Till then, goodbye.